Hello, you are welcome to this class. My name is Dr. Kingsley. In this class, I'll be teaching us on how to make calculations on average kinetic energy per mole of gas molecules. Now, how do we get the formula on how to calculate the average kinetic energy per mole? Now, we can get that from, the pressure of a gas from kinetic molecular theory. We have already driven the formula for the pressure of gas from kinetic molecular theory. Now the formula for pressure, P is equals to N prime, that is number of molecules, multiplied by mass, then C squared over 3V. This is the formula for pressure of a gas. From this, we can get the average kinetic energy per mole of a gas. How do we do that? We can use this volume here, volume, to multiply the pressure here. When we do that, we'll have PV is equals to N prime M C square over 3. Okay? When we have this, I believe that we can go further on our derivation. Now, I want to do some little arrangements. Now, this thing can be written as PV is equals to N prime over 3, then multiply by MC bar square. Okay? Now, I want to introduce 2 at the numerator. I will also do the same thing for the denominator. That means there is nothing that have changed. What I mean is that when we have PV is equals to N bar over 3 into 2 over 2 MC squared. If you look at this arrangement, you find out that I have not changed this equation because these 2 actually can cancel these 2. When 2 cancel 2, this equation will still go back to what? MC squared. So mathematically, it is correct. Now, what do we do now? We want to bring these 2 here, factor it out, so that we'll be having PV here to be equals to 2N prime over 3, okay, into, because I brought these 2 out here, okay, to meet this one, what will be remaining here is 1. So I have 1 over 2 MC squared. Now, if you look at this equation, you believe that what? You agree with me that what? Kinetic energy is this. This is kinetic energy. Because kinetic energy of a gas is equals to 1 over 2 MC squared. Okay? You look at this, I look at this, is equals to kinetic energy. But if we are talking about average kinetic energy, we are talking about KE bar, that is average kinetic energy. Average kinetic energy here, we go with what? Average what? Speed. It will go with average speed. So average kinetic energy will be equals to 1 over 2 mass multiplied by what? Average square speed. So average kinetic energy goes with what? Average what? Square speed. Now, if we replace this with this to be average, we'll be having that PV will be equals to 2N bar over 3 into what? 1 over 2 MC bar squared. That is average speed squared. Now, having obtained this, we can go further to say that pressure multiplied by volume will be equals to, instead of what? 1 over 2 MC bar squared, we can actually replace it with average what? Kinetic energy. So we'll be having 2N bar over 3, then multiplied by the average kinetic energy. Now, if we cross multiply, we'll be having 3 PV will be equals to 2N bar, then kinetic what? Energy. Average. Remember, this N bar is number of what? Molecules. And number of molecules by formula is equals to number of moles multiplied by Avogadro's what? Number. So I can replace number of molecules, which is equals to number of moles times Avogadro's number here. So what I will be having is 3PV will be equals to 2 number of mole, number of Avogadro's number, okay, then multiply by kinetic energy average. That is average kinetic energy. Now, if we look at this very well, you agree with me that, of course, that 3PV, or we agree with me that PV here, that is a pressure multiplied by volume, is actually equals to what? nRT from ideal gas equation. I hope you can see. Now from ideal gas equation, pressure multiplied by volume is equals to what? nRT. So we can replace it here. When we do that, it means that we should be having 3 multiplied by what? nRT. nRT will be equals to what? 2 NA, okay, then multiply by what? Multiply by kinetic energy average. So there is number of moles here, there is number of moles here, they will cancel out. So this will cancel this out. That means that 3RT will become equals to 2NA what? KE average. That is average kinetic energy. Now if we look at this, we see that what? 1 mole is equal to 1 mole of a substance. 1 mole of any substance is equal to what? The Avogadro's number of particles. 1 mole of any substance is equal to what? Avogadro's number of particles. That means that Avogadro's number of particles, which is Na here, is actually equals to 1. That is 1 mole. So that means that this equation becomes 3RT will become equals to 2 multiplied by 1 mole, then multiplied by what? Kinetic energy average, or the average kinetic energy. That is to say that 3RT will be equals to what? 2 multiplied by kinetic energy average, or average kinetic energy. So what does it mean? It means that what? The average kinetic energy, are you seeing from here? The average kinetic energy will become equals to what? 3RT divided by 2. So in view of that, we can conclude that average kinetic energy, okay, will be equals to 3/2RT. So this is formula that we can use to calculate the average kinetic energy of a gas. Now let us take one question. Find the average kinetic energy per mole of a gas at 27 degrees Celsius. Okay, R is equals to 8.314 joules per mole, okay, per Kelvin. All right, so find the average kinetic energy per mole of a gas at 27 degrees Celsius. R is this. You might be surprised. The R in gas laws is 0.0821 dm cube per mole. Dm cube, okay, atm per mole per Kelvin. But here we are using 8.314. Why? The reason is because we are looking for energy, and energy value is in joule. So your R unit should also be in what? In joule. So that is the reason why that value has changed. It's just due to conversion of units. Later I will show you how to convert, okay, the unit from 0.0821, okay, to this. Now, having done this, we are looking for average kinetic energy, okay, that is what we are looking for. Then our temperature is 27 degrees Celsius plus 273, because we will convert it to what? To Kelvin. Then our R is equal to what? 8.314, okay, joules per mole, okay, per Kelvin. That means that the average kinetic energy we are looking for is 3 over 2 what? RT. So the average kinetic energy, K average, will become equals to 3 over 2 multiplied by R, which is 8.314, okay, joules per mole, okay, per Kelvin. Then multiply by the temperature, which is 300 what? Kelvin. Then everything, when you multiply out, our K will be equals to, by my calculator, if I multiply out, I'm getting 3741.3 joules per mole, okay, per Kelvin as the answer. I hope you'll be able to, okay, do calculations on average kinetic energy per mole of a gas. That is the importance of this class. Please always share, like, and subscribe to my videos. Subscribe so that I can get to so many people that need it. Thank you very much.